Chapter 6.3, Solving Systems Using Eliminations. So far we have solved systems using graphing. We've solved it using substitution. Today we're going to solve systems using elimination. So let's jump right into it. In example 1, I'm going to solve a system by adding two equations together. So here are my equations, and I've rewritten them down here. 2x plus 5y equals 17, and 6x minus 5y equals negative 9. Now, in the substitution method from 6.2, we learned that we need to eliminate one variable. Instead of substituting one variable for another, instead here, I'm going to add these two together. And the reason I'm going to add these together is because I see right here that plus 5y minus 5y equals 0. If I add 5 and I take that same 5 away, I have nothing left. So I'm going to eliminate y by adding. So here I have 2x plus 6x equals 8x, plus 5y minus 5y is 0, and 17 plus negative 9 equals 8. So then I solve for x, divide both sides by 8, and x equals 1. Now I know that my answer is going to be an ordered pair because all of my solutions are ordered pairs. So I'm going to go ahead and put the start to my solution over here. Now that I know that x equals 1, I can take that and substitute into one of the other equations. I'm going to go ahead and pick the first one. So 2 times 1, substituting this one for x, plus 5y equals 17. 2 times 1 is 2, so I'm going to subtract 2 from both sides. 5y equals 15. Divide both sides by 5 so that y equals 3. So there is the other coordinate for my ordered pair. So the pair 1, 3 is my answer. If you try plugging 1, 3 into both of these equations, they will both work. So this first time I added, and the reason I added is because I had a positive and a negative that canceled each other out. Over here in example 2, we're going to solve a system by subtracting equations. But first I have to write them. So the theater club sells a total of 101 tickets to its first play. A student ticket costs $1, an adult ticket costs $2.50. Total ticket sales are $164. I'm sorry, $164. How many student tickets were sold? So I know a student costs $1, an adult costs $2.50. The total was $164. Sold a total of 101 tickets. So, define your variables first. X will equal student tickets. Y will equal adult tickets. You can do that the other way around. It doesn't matter. So 101 tickets. I know that X plus Y, the number of student tickets plus the number of adult tickets, is equal to 101. I also know that a student ticket costs $1. Well, 1 times x is x. An adult ticket costs $2.50, so 2.5y is equal to $164. Now, if I were to add these two equations together, x plus x is 2x, and y plus 2.5y is 3.5y. That doesn't eliminate a variable. So instead, I'm going to subtract. Because x minus x is nothing. y minus 2.5y is negative 1.5y. And 101 minus 164, 164 minus 101 equals 3, negative 63. Divide both sides by negative 1.5. And y equals 42. So I know that there were 42 adult tickets, but my question asks how many student tickets were sold. So I'm going to plug this back into my equation. X plus 42 equals 101. Subtract 42 from both sides. And x equals 59. So there were 59 student tickets sold for the play. So again, I want to eliminate a variable, so I'm going to subtract this time so that my x's are eliminated. That's why we call this the elimination method.